So Bioventix is an antibody company, and we're involved with blood testing. And this is large-scale bulk blood testing that takes place in hospitals around the world, where blood samples are collected for testing. They're tested on large automated platforms that are provided by large multinationals who manufacture the machines and the reagent packs that power the machines with the reagents that they require. And this market is dominated by big multinationals such as Roche Diagnostics, Siemens, Abbott Laboratories, and Beckman Coulter, and increasingly some Chinese competition. When blood is taken for testing, the robot inside the machine dips into some reagent that's required to perform a particular blood test. That reagent often contains an antibody, and the antibody will be to whatever is being detected in the blood. So if it's a testosterone test in a blood sample, in the reagent pack, there will be an antibody that only binds to testosterone, and that binding event is detected by the machine and quantified. So the antibody is naked, it doesn't have these two light green blobs in the reagent pack, but when the green blobs from the blood are bound by the antibody, that's the event that the machine detects through some complex chemistry. So what we do at our little lab in Farnham is we create new antibodies as part of our research, then antibodies that are of use to the outside world, to our customers here. We sell them through bulk after having bulk manufactured the antibodies all at our lab in Farnham in Surrey. It's all based on the premise that if we make better antibodies, they can facilitate better tests, and that's of interest to our customers and the users of the blood tests. So we sell physical antibody, and we sell around 20 grams of antibody a year, but we also derive a downstream benefit from the use of the antibody. So whilst we do not manufacture these reagent packs, when they get sold by our customers, such as Abbott, Roche, Siemens, and Beckman, to hospitals around the world, we derive a small percentage benefit from that downstream transaction. So that's why I talk about physical antibody sales and also royalties. That's an important part of our business. So our biggest seller is an antibody to vitamin D for vitamin D deficiency testing. We have some important antibodies for thyroid function. We've made antibodies against all of the relevant fertility hormones or steroid hormones, testosterone, estradiol, progesterone. We've made various antibodies for use in heart disease testing. So this would be heart attacks and more chronic heart failure. So that's troponin and BMPs. We've made some antibodies for drug testing. Now, it's worth noting that all of the blood testing machines throughout the world do not yet have any blood tests which measure what's going on in your brain. And I'll come on to that later, because I think that's something that will change in the coming years. But we've made around 25 antibodies that we sell globally to every single blood testing company buys at least one of our antibodies. We generally make our own antibodies through our own funding, our own reagents, and our own know-how, but we do occasionally have R&D contracts, such as the one with Siemens and troponin, where we were paid to make the antibodies. And when that's the case, we can only commercialize with the partner company. What happens when we create antibodies is at time zero, we have an idea to do something, to make an antibody to something that we think might be of interest. Then reagents are manufactured, and we immunize sheep. We take out sheep white blood cells, and then we perform our technology to immortalize those white blood cells, to ferment them and make small quantities of antibody. So at the end of a year, we'll have some small samples of 1 or 2 mils, a few milligrams of antibody, maybe a number of antibodies, which we will have at the end of that year's worth of research work. What then takes place is that we FedEx these samples to our customers, who are hopefully have an interest in whatever idea it is that we've conceived of in the previous year. What then happens is that the antibodies arrive at the prototyping labs of our customers. They then have the ability in a research setting to create a prototype reagent pack using similar techniques to the manufacturing departments that they're associated with, to create a reagent pack using a guest antibody that's been created and supplied. Then using blood testing machines and frozen samples, they then have the ability to compare the performance of this prototype pack with some existing test or other gold standard test. And you always get a scatter of some description. And that may lead them to the conclusion that the prototype test is of no merit. Or it may well be that it's some of these outliers demonstrate that actually the prototype has an improved performance. If that improved performance remains of interest to the commercial activities of the company, then that prototype test that's been formed will then go through further development until the point of licensing and regulatory authorities around the world. And typically all these blood testing companies, they'll have one antibody, one prototype, one test, one global offering. In order to go through this development process, there's quite a lot of resource required to conduct field trials, quality development, manufacturing development, stability studies. All of that ends in a filing which they can then present to substantiate the utility of this new prototype test. And that all takes quite a long time, and that's 2 to 4 years. So adding on to that year there, there's quite a lead time or lag phase between any research that we do in our lab and any successful launch of these blood tests around the world. The obvious observation being that these blood tests and the machines are highly regulated all around the world. So there is a natural lag phase between research and revenue. The other fringe benefit for us, and it's quite an important one in terms of revenue continuity, is that if you've made an antibody that goes through this process, after the test has been registered globally featuring your antibody, then in order to replace your antibody for whatever reason, then the company would have to then repeat a number of steps in this approval process, because the antibody is a crucial part of the test, and so changing it requires a repetition of elements of this approval process. And that natural reluctance to change does facilitate a reasonable degree of revenue continuity from the point of view of us and our antibodies, providing your antibodies have been selected for this process. If they have not been selected, then generally speaking, the ship has sailed and you cannot get back in and encourage someone to revisit a test if they don't want to. So that's quite an important aspect of our business. Regular viewers will know that our business is very profitable, and that's no change in this year's results. So our revenues have gone up by 6%. Profits before tax have gone up by 5%, but profits after tax have gone down by 3%. Now, some of you might be aware that we are now in an increased tax environment, but I'd also like to point out that it's not entirely Rachel Reeves' fault, because the corporation tax actually went up from 19 to 25% under Jeremy Hunt. So we cannot blame that on Rachel Reeves. Obviously, there are other things that we could blame on Rachel Reeves, but more on that later. So yeah, we are highly profitable with the cash generation, and we share that with our loyal shareholders in the form of dividends, which over the last few years have equated to sort of 2 or 3 or as much as 4 or 5% of the share price, depending on what the share price is doing at the time. Some issues for accountants. I suggest if you're interested in any of these, then study the detail of the accounts. But corporation tax, I've mentioned, we had a write-off for an old investment. We've had some changes in customer reporting. The revenues that we receive in the form of royalties are not quite as visible as one might like them to be, and we rely on the honesty of customer royalty reporting, which I have genuine trust in, but also the accuracy. And as you know, with accountants, even accountants make mistakes, and we are subject to that. But actually, these things balance out, so it's kind of not too much in that. And ditto, we had a Chinese royalty that was understated in our accounts. But again, it doesn't actually change too much. So if you're really interested, do check the details of our published accounts. That's a kind of more detailed summary for the semi-accountants, which I'm not going to go through. This is a bit more interesting. This is the different antibodies that we sell and how they performed in the last year compared to the previous year. So vitamin D is obviously very big for us, and after many years of growth, that has now steadied in its sales performance, and I think that will be the shape of things to come. Vitamin D being a very mature diagnostic product, and it's a mature antibody in that field. Similarly, many of these antibodies to T3, the progesterone, estradiol, testosterone, the steroids, they're all in very mature products, and the sales each year go up and down a little bit, but they're part of a historic core of very mature products. Troponin revenues actually were a little bit of a disappointment for us this year. We had expected revenue, particularly from our partner company Siemens, to go up this year, and that didn't happen. And it was certainly against the expectations that we had, and also our analysts at Cavendish. That was a degree of disappointment. Keep in mind here this revenue for tau and neurological products. Now, these are very, very new antibodies that we've only just made in the last year or two. So to have quite significant sales of antibodies so quickly, when actually I've just said it takes years before we have any sizable revenues, is quite a significant observation, and I'll explain a bit more about that coming up. Yeah, vitamin D, as I mentioned, is mature. Troponin was disappointing and flat, but there is cause for optimism that we will actually see growth from troponin in the coming period as a result of a new FDA label claim that they have, and I've got a slide coming up on that. So core antibodies are largely in mature products. Sales to China have continued to grow, which is great, although if I were to say to you, I perceive a certain degree of threat from emerging Chinese companies and antibody companies and onshoring of technology. You shouldn't be surprised about that, because I think those are trends that exist in other businesses other than Bioventix. Yeah, and this sales of 155,000 from nothing. And this has come from us sending samples for people to evaluate. So we give little samples free of charge. And if they then want to take their prototypes further, they then have to pay for additional supplies. 155,000 pounds is a lot of antibody. So that's been a very pleasing development as those sales have grown. So this is the issue I mentioned relating to Siemens and troponin. Now, troponin has been used historically in accident and emergency centres for people with chest pain to help determine whether those patients with chest pain have had a cardiac event and need to go to the stent ward. Sometimes it's obvious and sometimes it's not, and measuring troponin levels can help diagnose a cardiac event which will warrant a visit to the stent clinic. So that's a historic use of troponin. What Siemens have now shown is that not in A&E, but in cardiology clinics with people who are visiting regularly, if you just measure the troponin levels of these relatively healthy but at-risk people, you find very clearly that people with the higher levels of troponin are at a much greater enhanced risk of a serious adverse event in the coming weeks and months. And that information is important because it will enable clinicians to consider additional diagnostics and scans, and also to consider reviewing therapeutic options for a patient who you know is at serious risk of an impending event. So that's something that Siemens think will drive additional sales, and any additional sales will translate into additional royalties from our perspective. So that's something that we're cautiously optimistic about for next year. Alzheimer's disease. This is a simplification of Alzheimer's disease, but I think it's still relevant, and I think it's informative. And what this does here is highlight some of the key biochemical changes that take place during Alzheimer's disease. The first of these is the buildup of amyloid plaques in between neurons, nerve cells, or neurons as they're known. And secondly, these tangles. So inside these axon structures, there's an internal skeleton that becomes disrupted and falls apart, and you get and it's made of these tau proteins that form these unfortunate tangles rather than the neat skeletal tube-like structures that they normally adopt. One or both of these events result in cell death. So you get the nerve cells dying, so the brain cells die. And when they die en masse, it's visualized through shrinkage of the brain. And that process of loss of brain matter is called neurodegeneration, which kind of fits the bill. So these processes of amyloid buildup, tau tangle formation, and neurodegeneration take place over if you can't quite see that, this is onset of disease -10, -20 years. So it gives you an idea of the time scale of the development of the Alzheimer's disease process. These changes can be detected using brain scans. So these are PET scanners with tracers, so that you have a tracer which binds to amyloid, which lights up the amyloid plaque. Or you can get a tau tracer which shows up a bit later and lights up the tau tangle that are formed. And on magnetic resonance imaging, you can clearly see the shrunken brain formation that kind of looks very similar to that Wikipedia sketch up there, where you can see holes and ventricles forming inside the brain as the brain shrunk over time. So all of these processes take place over many years. What's changed fundamentally over the last couple of years is the perception of Alzheimer's disease, particularly from the point of view of the pharma companies, who have previously considered Alzheimer's to be a potential gold mine, but in actual fact, a graveyard for therapeutic product development. There's numerous clinical trials, drug after drug after drug, have failed after hundreds of millions of dollars of investment in clinical trials processes. What changed in September 22 was Eisai Biogen announcing the results of a phase 3 study where they showed very clearly that their therapy cleared these amyloid plaques, resulted in changed brain scans using amyloid PET, and crucially had an impact on the neurological function of those patients. Now, as to whether these drugs are blockbusters, we'll have to wait and see, but it's certainly changed the perception of Alzheimer's back to being a real blockbuster zone. And it's turbocharged additional interest from the entire pharma industry in Alzheimer's therapies. I think the future looks great for Alzheimer's therapies into the 2030s with second generation therapies, combination therapies, which will all be cheaper, more effective, and have lower side effects than the generation 1 therapeutics. So the future is bright for Alzheimer's therapeutics. Obviously, we are not into therapeutics, but it has had an impact on the perception of diagnostics. Because in order to operate all of this in a therapeutic mode with a drug, you would need to have blood tests that mimic all of these scans, because you cannot screen for patients using PET scanners because they simply aren't enough, maybe too expensive. So blood tests which could mimic the results of these expensive brain scans would be highly desirable. So that reality has changed the perception of diagnostics over the last couple of years. The blood tests that people are currently focused on, so I've made the point here, it's a rapidly evolving field, and a field that is developing so quickly and with great enthusiasm at our customers at Abbott, Roche, Siemens, and Beckman, etc. So there are blood tests which, for the early phase, a blood biomarker called phospho-tau217 has been identified, which works really well in terms of detecting Alzheimer's early. There's another particular target on this tau protein at this position here, which is clearly linked to the neurodegeneration part of the Alzheimer's disease process. So again, that blood test or prototype blood test works really well. So these have got a clear route towards going towards significant utility in blood testing, in the world of blood testing. The final bit of the jigsaw, or the third bit of the jigsaw, is an area of active research. And many people think that some antibodies or biomarkers in this so-called MTBR region here will form the third and final part of the Alzheimer's jigsaw. We're working on it, but I would say that there isn't a clear picture of exactly what exists here. So what's happening right now is exciting because all of our customers are developing prototypes for this panel of diagnostics. There's a whole new offering that will become available on blood testing machines in the future. And obviously, it's important that we are part of it in some way with antibodies against these targets and also detector antibodies, which can be important in this region here. So it's important that we become part of this in the years to come as assays get prototyped at our customers using our antibodies, and hopefully some of our antibodies will get through into the final selection for commercial assays for the future, and we will benefit from that. We have some other things in the pipeline. Secretion urine actually is the subject of the write-off, so that is no more. We have another project in Oslo. I'm running through these quickly because they're of less significance if compared to what I think will be blockbuster diagnostics in the future. There's another company in Oslo that have another antibody project for a side effect of Alzheimer's therapy. We are involved in some industrial biomonitoring where we've made antibodies and lateral flow tests for industrial pollutants, pyrene for combustion, benzene for the petrochemical industry, and isocyanates for the polyurethane industry. We've also got a new project which we haven't mentioned previously in the area of water quality, and I'll say a little bit more about that. On the area of water quality, you've all seen the news, you've read the Times, you heard on the BBC that there's a national scandal that our river systems do not look like this. If you look, the closer you look, you find that actually it's what we paddleboard in and triathlon in is actually a mixture of pure and sewage. So the concept of our new project is to, instead of measuring E. coli, which is what gives you, sickness and diarrhea, you measure a surrogate of that, which is paracetamol or caffeine, which you can do at the riverside, and to find out exactly how much sewage is in by virtue of testing for the human-derived drug. So that's something that we're working on right now. We're just trying to develop these lateral flow tests, which will be QR coded and phone friendly, so you better upload your result to a global river system database. That's quite an interesting development for the future. This is kind of what we've been doing for many years, which is to seek new targets, to focus our technology on that and keep the team as is and retain our know-how. Picture of our lab down in Farnham, where we've got facilities for culturing cells, purifying antibodies, large-scale production in these bioreactors, and some antibody technology development. I've only got a team of total of 14 people, 12 full-time equivalents. So it's a very, very small company, but no one's left for 6 years. So we're trying to recruit a new graduate just because the old new graduates are now 30 odd. That's me, Ian, the chairman, Nick standing down, Joe's great, Bruce is our finance director. Main shareholding are some household names you might have heard of. I still hold 6% from the old days. So yeah, the last year has been solid in terms of vitamin D and our other antibodies. Troponin a bit disappointing, but I think that's got scope for increase in sales in the future. And I think that what's going on with tau and Alzheimer's is really, really exciting. And I hope and I'm cautiously optimistic that we'll be part of that in the years to come.
There's one online which I'll fire off with from Mark Bentley, which says, please describe your positioning relative to competitors for Alzheimer's antibodies. I understand that several companies have antibodies tests.
Very, very good question. There's competition from people that have been in the field longer than we have. There's a company called Altspath who have got a really good phospho-tau217 antibody that's really difficult to compete with. In addition to that historic company, there are other companies such as Roche, Eli Lilly, and Biogen, who are slightly bigger than we are, who also have antibodies. So one might feel daunted by that. And yet I'm confident we still do make good antibodies. And the fact that people have repeat ordered our antibodies suggests that we're in the mix somewhere. So we've definitely still got a few horses in the race. So whilst that will shake out in the coming months and in the next year or two, there will be some fallers. So we just need to hope that our horses come through and are in the paddock at the end.
Thank you. I'm going to go to Mark. I'll pass the mic across.
Thanks. Couple of questions. For the Alzheimer's antibodies, is that a race that can have more than one winner, i.e. people having maybe 20–30% market share, and we will be in one of them or possibly even two? And second question, the antibody sales of 155,000, how many customers does that represent?
First question is quite an important one. I think the offering from the blood testing companies will be have a panel of 3, 5, 6 different tests. Each of those tests requires 2 antibodies. So in football, in terms of a lot of shots on target there. So there are a number of blood tests with a number of companies, we have some companies who I know are predisposed towards using their own antibodies because it's very much in their DNA. And so you send samples, and I'm sort of not that overly optimistic of it ever really having a breakthrough because I know they'd rather wait and use their own antibodies. We have some other customers who are actually in quite a hurry and they quite like using our antibodies. So with a couple of those companies, I feel a little bit more optimistic that if the prototypes work, then we will feature in the final selected antibody pairs that go into the commercial assays. Time will tell how that works out. The 155,000 is with more than 2 companies. There's a couple of companies in there.
Okay, I understand that I think last month or so there was some Nobel Prize awarded so that people can predict the protein structures quite easily, and that I'm just wondering, is that something that your company can make use of, or pharma companies are making use of, that's feeding through to you?
I do have a 25 yards breaststroke certificate, but I do not have a Nobel Prize. So I want to make that absolutely clear. Protein structure and folding, I think it's a fascinating area, but we're not involved with that though.
I was just wondering if you could elaborate on the use of troponin in cardiology departments. You said that's another possibility. You touched on that as opposed to in emergency situations.
Yeah. Well, it's down to the fact that troponin, the existing use of troponin, all troponin assays are commonly used in A&E settings where people are sat there with chest pain. Sometimes if someone's had a heart attack, it's blindingly obvious. And they won't get a troponin test. They'll go straight to the stent clinic where it's obvious. But if someone's there and the chest pain is gone, and they're kind of feeling a bit better, it's not obvious to determine whether they've actually had an event or not. If they have had an event, they may still need to go to the stent clinic. So that in A&E, the test is used to measure increasing levels of troponin, which tell you that if the troponin levels are going up over a period of a few hours, then they've got heart muscle that's dying. Whereas in cardiology, people have had a previous event and they're turning up just for regular consultations in cardiology. It's in that second setting for which troponin has not previously been used, that if you measure troponin, which is now possible, for people with high levels, you know that they are sick and that you have the opportunity to intervene and do more for them. And that has value for the sake of a few dollars.
Is that widely done?
It's only been talked about over the last couple of years with opinion leaders who are probably still already doing it because they've proved to themselves that it's helpful to them and their patients. So I think it's happening at leading clinics. With a label claim, Siemens salespeople and applications people can then spread the word and get it into more routine use.
Two questions. One, are there any specific reasons why you're not using AI programs like AlphaFold from DeepMind and stuff like this to generate new, let's say, molecules or something, antibodies, something like this?
We operate at the opposite end of the spectrum of AI. If you consider AI to be one of the most remarkably intelligent functionalities of human existence, we actually work with sheep, who are amongst the thickest of animals ever. And yet they still create amazing antibodies. And so I'm not aware of any in silico system that creates antibodies better than our sheep do. Rabbits are quite good, but I'm not aware of the ability to create an antibody using AI.
Cool. And my next question would be, how many new versions of antibodies are you able to create, and how many of them are viable?
Well, a sheep will create sort of 10 to the 12-ish, but of course, you have to kind of carefully go through that 10 to 12 to work out which ones might be of use to you. And so whatever you consider to be a useful creation technology, without a screening strategy, the argument's meaningless. It's as meaningless as giving my son a toolbox when he hasn't got a clue how to use tools, because he just hasn't had the know-how, despite the fact I've been telling him for years. More on that later as I'm seeing him.
Peter, how long does it take to produce the antibodies for Alzheimer's? I mean, the ones that you've created that work, and are you able to keep up with the required demand?
Well, the antibodies that we're selling now, we created 2 or 3 years ago, and that we're selling those for research use. And then the antibodies we're creating now are for this new tau tangle application, and hopefully there'll be some of those that will form part of the sort of tau tangle diagnostic prototype assays in the future. But we haven't really quite worked out with our esteemed friends in Gothenburg exactly if any of the targets that we're going for in this NTBR region are of use. And that's going to be ongoing. I can see us working on tau well into next year, probably towards the end of next year.
Any more? I'm going to ask the elephant in the room, which is your share price. We've heard about Rachel Reeves, and we've blamed her a little bit, but I think there's more going on there this year than just Rachel Reeves. Can you elucidate at all?
Well, on issues of share price, I tend to ask Bruce, actually, just because he knows much more about share price movements than I do. I stick to antibody technology in the belief that the long-term creation of value will have an impact on share price. Short-term variations, I tend not to lose too much sleep over. Long-term value creation, I think, is more relevant. That's my job. So, yeah, Bruce, what is going on out there? Yeah, I don't have any. You guys have a much better understanding of market dynamics than I do. I observe it with my simplistic view of Bioventix is that we've got a certain floor which is based on the dividend flow. So below, I mean, when it crashed below £30, there would have been a number of people thinking, wait, that's kind of like 6% yield. That's quite generous. And obviously it gets too frothy. People think, oh, that's the PE ratios are a bit silly. So I think my understanding is that our share price moves within a certain range, or with a quite well-defined floor and a frothy ceiling. That's a short-term thing. Of course, my main concern is translating things like the tau product into long-term value, so that the whole range of movement is shifted upwards through genuine increase in sales and profit and value.
Okay, it just seems a little strange that the news is stable and the reception by the market has been. I mean, I guess that's partly AIM writ large at the moment, but
you guys know more about that than I do.
Super. I'm not seeing any more online questions, so Peter, I'm going to thank you very much indeed.
Thank you. Thanks, everybody. Thanks for listening. I hope you found that interesting.